Okay, listen now. Let's start. Listen. Let's start our lesson, the new lesson, which is 2.1. Okay. 2.1, which is talking about the graphs of equations. Okay. Before we start, let's read what you should learn. Who can read it? Shahid? Check, Shahid. Read it. Yes. Read it.
What should you learn? How? What should you learn? Sketch graph of equations. Find x and y intercept of graphs of equations. Use symmetry to sketch graphs of equation. Find equations of unsketched graphs. Use
Okay.
graphs of equation in solving real life problems.
Why you should learn it? Why you should learn it? Okay. Take it, Leon. Tell me why you should learn it.
The graph of an equation can help you see relationships between real life quantities.
Yes. Okay. So as you can see here, Noura, why we should learn it? Because we can see the relationship, okay, and the real quantities. Okay. After we finish the solving, yeah, Jana, please, Mariam. Okay. After we finish solving this, okay, so as you can see, we use we use the distance formula, which is x2 minus x1 plus y2 minus y1. Okay, just simplify. We have the coordinates. So the first coordinate is negative 2, 1. The second one, 3, 4. Just substitute them. Then you get, which is x point 5.883. Okay, so this is just a small introduction about what we need to learn. Okay, now let's start with the first. Okay, so as you can see here, example 1, determining solutions. So first here, we need to determine whether 2 and 13, also the other point, negative 1, negative 3, are a solution of equation which is y equal 10x minus 7. Okay, how we can know these 2 points as a solution? So we just plug them in the equation. So 2 represent x, 13 represent. Okay, so we just put here 2 and y, 2 and 13. Okay, so as you can see, we put 2 and 13, then simplify, we will get the same answer. So 13 is equal 13. So that means 2 and 13 is a solution. What he means about a solution? Okay, he means if we have, let's say, we have this line, okay, which is this line represents y equal 10x minus 7. Okay, so if you put 213, 213 will be on the line. Okay, we need to check negative 3, negative 1, negative 3. Is it on the line or just somewhere else? Okay, so to check it, we need just to apply these 2 points in the equation to see if the point is on the line or it's not on the line. Okay, so now if we apply the second one, what do you think? What do you think? Outside? Okay. So now let's substitute. So as you can see here, after we substitute negative 3 to the y, negative 1 to the x, we simplify, we get negative 17, which is not equal negative 3. So that's mean point 2 and 13 is not a solution. Okay? So this is how we can identify, okay? Yes, determining the solution. Yes, tell me, Nora, what's your question? Okay, let's go next. Okay, example 3. Now let's sketching the graph of any equations. Okay, so let's sketch the graph. So let's take this example here. So this example, which is x to the power of 2 minus 2. Okay, so this one is like a polynomial with degree 2. Okay, so how we need to solve to graph this one. So just pick a random point. Okay, so let's pick negative 2, negative 1, 0, 1, 2, 3, just a random point. Then plot these points in the x here. So negative 2 to the power of 2 equal 4 minus 2 equal 2. Same thing, negative 2, 1 minus 2 minus 1 minus 2 minus 1. So just keep them. Then we have the coordinates. Okay? X, Y, X, Y. Then let's plot them on the graph here. So if we plot the coordinates on the graph will look like this, right? So what do you notice from the graph? So it's look like what? The parabola or the quadratic, right? Okay, but the parabola or the quadratic, the original one, it does look like this, or what's happened to the original and this? So what's the difference? Yes, Tommy. Thank you, Noor. Yes. So the parabola, we know it starts from 0 like this and goes like this, right? This is the normal. But what's happened to this one? Shifted down, okay, 2 step. So that's why we added a -2 here. The -2 represent this one is goes down. How many steps? Okay, 2 units. Okay, 2 units step, two down units. Okay, so this is what's happened here in this graphic. Yes. Now let's identify the intercept. Okay, so let's identify the intercept. Okay, who can read this one? Who can read it? Maria, read it.
It is often easy to determine solution points that have 0 as either the x coordinate or the y coordinate. These points are called intercepts because they are the points at which the graph intersects or touches the x or y axis. It is possible for a graph to have no intercepts, or similar.
Perfect. So as you can see here, the graph it could has no intercept, one intercept, or several intercept. So look to these 3 graphs here. So the first one here, no x-intercept, but there is one y-intercept. This is the y-intercept, so just the function it's intercept with the y and 1 point. Okay? Yes. And the second one here, how many intercept do we have? Yes, the 3 on which axis? And where is the y one? Which is this one here, which is 0 and 0. 0, 0. Yes, not 0, 1. Okay. So this is 0, 0. Okay, it's shared between the y-axis and x-axis. Okay, this one is 1 x-intercept, 2 y-intercept. So as you can see, this is 1 intercept and 2 y-intercept. Okay, now to find the intercept, how we can find when the graph is at x or the graph is it on the y-intercept? Yes, when we can find this, read here, find the intercept. First, to find x-intercept, so to find the x's here, okay, to find the x-intercept, let y equal what? So we will replace y with what? 0, then we can solve the equation for what? X. And to find the y-intercept, okay, to find the y-intercept, which is this point here, what we need to do? The y-intercept, we let what? We let x equal 0, so x which will be equal 0, okay, and solve equation for y. Clear? Okay. Okay, let's continue. Okay, now let's take an example about how we can finding x-intercept and y-intercept. So first of all, we have this equation here, which is y is equal x to the power of 3 minus 4x. So this is what type of polynomial? What type of polynomial this? Cube. Cube, right? Yes, cube, which is third degree, right? So do you remember how this degree look like? The cube function. Do you remember what the graph look like? It's like this. Do you remember this? Okay. So this is the cube function. Okay. Now let's find the x-intercept. So now to find the x-intercept, what I have to put? Replace y with 0. So now if I replace y with 0, so now y is equal 0. So I just solve the equation easily. So as you can see here, y it will equal 0 equal all of this. So 0 is equal x to the power of 3 minus 4x. Then now let's simplify this. So what's the common factor here? X. So x times x to the power of 2 minus 4. Minus 4. Okay. So now this one x to the power of 2 minus 4 is the difference. Okay. The difference of square. So now let's simplify this one more. So as you can see here, so this one can be x minus 2 and x plus 2. So now the first x is equal what? 2. The second x is equal what? Negative 2. So it's like this. X equal plus 2 and x equal negative 2. And there is x here. So this x here represent what? X equal 0. Don't forget this x. So now we have a 3 coordinate, 3 x-intercept. The first one is what? 0, 0. The second one is 2 and 0. And the third one, negative 2 and 0. So we have a 3x intercept. Clear? Now let's find the y-intercept. So to find y-intercept, what we need to do? Reem, to find y-intercept, what need to do? Yes, replace x with 0. So after we replace x with 0, so 0, 0, 0, so y is equal what? Y is equal 0 because there is no any value. So my y-intercept is equal 0. Okay? Now, if we look to the graph of the of the cubic function, it will look like this one. So the first intercept, okay? So the first intercept is -2 and 0. The second intercept is 0, 0. The third intercept is 2, 0. So we have this one and we can graph the cube. Okay? Clear? Any question on this?
Uh,
Graphs of equations?
Graphs of the equation can have symmetry with respect to one of the coordinates axes with respect to the origin. Symmetry with respect to the x-axis means that if the Cartesian
Plan.
plane
Mm-hmm.
were to fold along the x-axis, the portion of the graph above the x-axis would coincide with the portion below the x-axis. Symmetry with respect to the y-axis or the origin can be described in a similar manner.
Thank you.
Yep.
Thank you, Nora. Okay. So as you can see here, okay, so as you can see here, all of these, just let's summarize this one in these 3 graphs. So as you can see, when we have a symmetry over the x-axis, okay, so this one, symmetry over the x-axis. So as you can see, this is the x-axis, and my graph will look like this. So it's symmetrical to the other side, which is like this. Okay, so this is over the x-axis. And for the y-axis, so for the y-axis, you can see here, we have this one on this side. It's similar or symmetrical to the other side of this function. Okay, and we have the last one. We call this one the origin symmetry. The origin symmetry, okay, the function that goes, let's say, above, okay, on the other side, the functions will goes to the down. Okay, so let's say my function, let's say another example. Okay, so let's say my function here, okay, is increasing like this and then go like that. So the origin symmetry, so this one, it will not go up and goes down like this. It will go down, then will go up, because this one goes down, then goes up, which is like opposite or flipping your equations. Okay, so this is about the origin. Now, graphically, if we read all of these, how we can find them? So in the first one, when the x-axis, okay, we have the coordinate xy, so it will be x and negative y. Okay, when we are talking about the y-axis symmetry, so my y-axis, the xy, it will be the negative will be at the x-axis. Okay, when we talk about the origin, x and y, both of them are equal in negative sign. Okay, so this is how we can identify symmetry, let's say algebraically. Okay, so when we have a coordinate, let's say x and y, when I give you x a negative, so this is a symmetry over what? Over which axis? When we have x is negative. Symmetry over which one? Y-axis. Thank you. Okay. Okay. Now let's test the symmetry here. So as you can see here, we have the same function that we graphed before, which is this one, the parabola. Okay. So now if we applied, see here, if we applied the x-axis, as you can see in this table, -3, -2, -1, 1, 2, 3. So as you can see, we have the points, okay, and we plot them here. So as you can see, the symmetry of this parabola, okay, over which axis? Y-axis. Why it's over y-axis? Because x is negative and y is positive. Okay, clear? Clear? Okay. Now, can you solve this question by yourself? Yes, try to start solve them. Okay, try to solve now these questions. Try to solve them, girls, after we finish them. Okay, guys, yalla, have a good day. We are going to continue tomorrow.